In video 3.2, we will be working with the Pythagorean Theorem. You should be able to say, I can use the Pythagorean Theorem to find missing lengths of a triangle. The Pythagorean Theorem will work for any right triangle like we have here on the screen. In this right triangle, you always have legs, which are your two shortest sides. So in my picture, here is one leg, and here is the other. The hypotenuse is the other side. That's the longest side, opposite of that right angle. So you can see I have my right angle here represented in orange. Across from that, that is called the hypotenuse. The theorem is a squared plus b squared equals c squared. And what it does, it helps us find a missing length of a right triangle. It'll work for any right triangle when we're trying to find a missing length. The a and the b are the legs of the triangle. The c is the hypotenuse. So let's take a triangle. Here's our right angle. We're going to say our legs are 6 and 8, and our hypotenuse is x. And we want to figure out what that x is. We're going to use a squared plus b squared equals c squared, which is our theorem. We'll say that the a is 6. Now we could say that the 8 is also a. It doesn't matter what you say is a, what is b in terms of the two legs. So let's just say that a is 6 for this one, and we'll say then the b is the 8 because those are the two legs, and the c is what we're looking for. Now if you want to represent it as c, or you can replace the c with x, that doesn't matter. Once again, the 6 and 8, it could have been a or b because of commutative. We're just adding. So we have 36 plus 64 after we simplify our exponents. And 36 plus 64 is 100. So when we're figuring out c here, we have to figure out what squared is 100. And we've been working with perfect squares, and we know that 10 squared is 100. Now, the other thing with algebra, if you're squaring something, like here, we're squaring our c, and I'm going to change that, you can undo the square by finding the square root. And if you do the square root to the right side of an equation, you have to do the square root to the other side. Now what happens underneath the square root on the right side, I want to know what's being squared here. Well, c is being squared. So what happens is that radical cancels out the power of 2. So now c is alone. The square root of 100 is 10. So x is 10, or the c, the hypotenuse, is 10. Here's another triangle. We're going to pretend that this is a ramp. And the ramp is 5 feet above the ground. The distance from the beginning of the ramp to where that ending is down here by the right angle, that distance we're going to say is 16 feet. And we need to know how much material we need to make this ramp. And we're going to round to the nearest foot to figure this out. So we have a squared plus b squared equals c squared. We'll say that the a is 5, the b is 16. We're looking for c, or x. 25 plus 256. So when we add 25 and 256, we get 281. And so we want to know what number squared is 281. To undo the power of 2, remember, you can find the square root. If you find the square root on the right, you have to find the square root on the left. What's being squared under the square root is c. And what is being squared here for 281? What's the square root of 281? You get something like 16.76. Now if we round to the nearest foot, we've got 17 feet. Can you say, I can use the Pythagorean theorem to find missing lengths of a triangle? Here's your output to use 4 colors. Draw a picture, then write the theorem, then show your work, and then check your work. Find the hypotenuse of a right triangle with legs of 9 inches, round to the nearest inch. And then a right triangle has legs of 5 and 18. What is the length of the hypotenuse, and round to the nearest centimeter?